Johanna jogs along a straight path. For 0 to 40 minutes, Johanna's velocity is given by a differentiable function v. Selected values of the velocity of time, where t is measured in minutes and v of t is measured in meters per minute, are given in the table above. Use the data in the table to estimate the value of v prime of 16. To estimate the derivative of v of t at 16 minutes, you can use the x values of 12 and 20 along with their respective v of t values and implicate them into the mean value theorem. Using the mean value theorem, the answer to part A is found to be 5 meters per minute squared. The first part of part B is asking you to explain the meaning of the definite integral in the context of this problem. This integral can be interpreted as the total distance Johanna jogs in meters over the time interval 0 to 40 minutes. The second part of part B is asking you to approximate the value of this integral using a right-Riemann sum with 4 subintervals indicated in the table. To perform a right-hand Riemann sum, you must begin with multiplying the difference between the first two t values by the second t value's corresponding absolute value of v of t. The same pattern is continued for the rest of the table values. For part C, Bob is riding his bicycle along the same path. For time equals 0 to 10 minutes, Bob's velocity is modeled by the following function, where t is measured in minutes and b of t is measured in meters per minute. Find Bob's acceleration at time 5. To develop Bob's acceleration function, take the derivative of Bob's velocity function. To find Bob's acceleration at 5 minutes, plug 5 into the derivative function. Bob's acceleration at 5 is found to be 15 meters per minute squared. For part D, you are asked to use Model B from part C to find Bob's average velocity during the interval 0 to 10 minutes. To solve part D, you must know the average velocity equation labeled here. The time interval of 0 to 10 minutes, along with Bob's velocity function, are inputted into the average velocity integral. After inputting such values, you must integrate. After integration, plug in the corresponding time values and solve. The answer is found to be 350 meters per minute.